Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into
Motorists
it.
can often hear how they spin the engine up to the cutoff, or their power unit hits the cutoff. Basically, this happens when there is a need or desire to accelerate the vehicle to maximum speeds, or when the arrow from the tachometer enters the red zone at various speeds. It is important to realize that the cutoff is not at all a failure or malfunction of the engine. It is a rather useful function, which was built into the car by engineers. In fact, it can be used to further protect the powertrain from excessive loads and ensure that it operates in optimal and safe modes. In simple terms, when the engine reaches its peak load, a cutoff occurs. It prevents the engine from spinning up even more, as the engine is already overloaded. At such moments, drivers feel the powertrain does not pull, works with jerks. There are pauses in the traction. What it is and how it works. As we have already managed to find out, the cutoff is called a special, laid down even by design engineers, protection for the engine, which limits the maximum speed of the crankshaft. Because of this, the driver has the opportunity to raise the revolutions only up to the stipulated standard cutoff, but not higher. This helps to preserve the engine and protect it from extreme overloads. This means that the engine cutoff is a purely protective function and not a malfunction of the internal combustion engine. Now it is interesting to know how this cutoff works for the engine. In the case of modern injector engines, it looks like this. When during operation, the engine reaches the limit set during production, the electronic control unit disconnects or blocks the fuel supply to the working cylinders, which contributes to a reduction in shaft speed. Having already understood what the cutoff means and why it is needed in engine operation, it is worth talking about some equally important parameters. There are several characteristics applicable to the motor which determine the value of the peak load values that activate the cutoff. Here they take into account the speed of the vehicle, the current RPM of the crankshaft, exhaust pressure in a turbocharged motor, turbo motors. It is worth considering separately the existing varieties of cutoffs, which differ from each other in the principle of action, but pursue the same goal. This is to preserve the integrity of the engine and its individual components. Speed: there is a cutoff that is triggered when certain maximum speeds are reached. With this feature, automakers limit the maximum speed of their vehicles. Usually, the maximum speed cutoff is used in conjunction with cutoffs that respond to engine speed. In the case of the speed cutoff, it is used to prevent the car from accelerating beyond certain preset parameters. The rev limiter directly protects the engine itself when traveling at different speeds and gears. If the car is equipped with a speed limiter, then when the maximum value is reached, the electronic unit also cuts off the fuel supply to the working cylinders. This prevents the vehicle from accelerating further. As soon as the vehicle starts to drive within the set limit, i.e., the speedometer arrow drops below the peak, the ECU gives the command again and the fuel supply is resumed. In practice, it looks like this. The car accelerates to 250 kilometers per hour, which is the most common peak value for most modern cars with fairly powerful engines. At that point, the cutoff is activated. The driver simply cannot gain speed further, since fuel does not enter the cylinders. When the speed conditionally drops by 5 to 15 kilometers per hour, the ECU turns on the fuel supply, and the motorist can again gain speed. But when it again reaches the peak value, the block again turns off the fuel supply. This system is designed so that the driver cannot drive his car faster than it is provided by the cutoff. Some car owners are not satisfied with the fact that the speed of their car is artificially limited. A speed limiter is also often referred to as an electronic bracelet. In fact, it is a program code that is entered into the controlling electronic unit. To remove these artificial restrictions, the electronic brain of the engine is reflashed, getting rid of the limiter, which allows the car to go beyond the cutoff. To what extent there is a need for this, it is difficult to say. Read also, features of the operation of a 12-cylinder engine turbine. There is another type of cutoff. It reacts to the exhaust gas pressure in the turbocharger as well as the turbocharger speed. As you understand, this type of cutoff is used only on turbocharged engines. and such a solution is considered to be more effective than just the cutoff by shaft speed. The point is that the crankshaft RPM itself may not yet reach peak maximum values. That is, they do not threaten the integrity of the engine. But the same values become critical for the turbocharger. Working under such loads can provoke serious negative consequences and lead to turbine failure. And this is a rather expensive element of the turbo engine, which must be taken care of. The cutoff on turbo engines allows you to somewhat limit the speed of rotation of the turbocharger, which helps to provide additional protection from the destruction of the element. Crankshaft, the most common and actively used variant of the cutoff, is considered to be a limiter, which takes as a basis the speed of rotation of the crankshaft. That is, we are talking here about controlling the engine speed. Here, the cutoff has certain limits, above which it prevents the shaft from rising. Not only foreign cars are equipped with such limits on the revolutions of the power plant. Many people did not even know and did not even guess, but domestic cars are also equipped with cutoffs from the factory. The same Lada Kalina, is triggered at 6,500 RPM. This is approximately the same value of the RPM limit as is provided for the Korean cars Hyundai Solaris and Kia Rio, which are popular in Russia. The value of 6,500 RPM, at which the limiter, cutoff, comes into play, has become a certain established standard, which is rather conventional in nature. That is, it is not the same and mandatory for all, but on standard engines with relatively low power and torque, it is the cutoff. At 6,500 RPM is the most acceptable and suitable. At the same time, there is a wide list of automobile engines, where manufacturers provide completely different parameters of revolutions for triggering the cutoff. There are simply power units that are initially positioned as high speed, because of which in the standard mode of operation there, crankshaft rotates at a speed of about 7 to 8,000 revolutions per minute. And it is not quite right and correct to set the limit here at 6,500 RPM. In the case of sports cars, hypercars, and other heavy-duty vehicles with high-performance engines, the cutoff is set even higher. The cutoff is always activated after a command from the electronic control unit. It prevents the vehicle from continuing to gain speed if the crankshaft has already reached its limit, albeit artificially set. Automakers try to set the cutoff at a level at which the engine spins to 95 to 100% of its maximum operating speed. Engineers try to leave about 5% as a reserve and reinsurance from the limit values of revolutions, at which the engine is able to work without losses and serious damage to itself. For example, if the power unit has a standard limitation of 6,500 revolutions, then in reality such an engine can spin up to about 7,000 revolutions, but without being at its peak loads, contributing to destruction, rapid wear, and breakdowns. Such a reserve allows to create optimal conditions of functioning to prolong the life of the power unit. The RPM limit at which the cutoff will be triggered is easy to determine by yourself. To do this, simply look at the instrument panel. To be more precise, on your tachometer, the line from where the white stripe changes to red and is the very limit. When the driver brings the revs to the red line of the tachometer, the cutoff is activated. The ECU gives a signal and the fuel supply to the cylinder stops. As soon as the tachometer arrow drops into the white zone and the crankshaft RPM values correspond to the values stored in the ECU memory, fuel will start to flow into the working cylinders again. Useful tips. It is worth noting that modern cars are actively equipped with various limiters. And quite often it is possible to meet several different cutoffs on the engine, used simultaneously. This applies to forced and powerful atmospheric and turbocharged engines. Read also, Principle of operation of the engine cylinder deactivation system, the engine speed cutoff, is objectively more useful than harmful. It is difficult to call the limiter a disadvantage, as it does not actually limit the power or dynamics of the vehicle. But it allows you to keep the motor intact, prevent premature wear, and protect against serious breakdowns caused by overloading. Many people are interested in whether they can rev their engine up to the cutoff and whether the engine itself will not suffer. It is allowed, and we are not talking about any threats of damage to the power plant. Just do not go beyond the red line on the tachometer. There is nothing good in frequent operation of the car at high speeds, when the tachometer arrow is constantly in the red zone. This contributes to the reduction of engine life and the occurrence of certain malfunctions caused by excessive loads on the internal combustion engine. But the point is that there is no need to bring the revs to the red zone. This does not increase power or maximum speed, but only decreases it. Engineers have designed the engine to reach its maximum power at certain and rather high crankshaft speeds. This is about 90 to 97% before the cutoff. Let's assume that the car has a rev limiter at the standard 6,500 RPM. This means that you will be able to reach the maximum power of your motor at about 6 to 6,300 RPM. That is, you have not yet reached the cutoff point, but you are a short distance away from it. If you go beyond the cutoff, the power will immediately drop, the speed will stop, because there is no more fuel in the cylinders. You will only try in vain to squeeze the accelerator pedal, destroying the pedal assembly itself and causing more trouble with your completely unnecessary and unjustified actions. If you want to get the maximum efficiency from your engine, to feel its performance, keep the revs close to the cutoff, but do not cross this line. Running the engine in this mode is perfectly safe. There is no risk of damage or excessive wear from overloading. The engine is now operating in the optimum mode to which it was originally adapted by the designers. When tuning the engine, the cutoff limits are sometimes shifted upward to increase engine output. Sometimes the limiter is turned off completely, giving access to the full power and maximum speed the car is capable of. Blocks where the cutoff can be shifted theoretically give a boost in power and increase top speed. But such tuning increases the load on the engine, which begins to wear out and fail faster. In order to disable the cutoff or shift it, you need a specially prepared car, the engine design of which uses strong, wear-resistant, and reliable components that can withstand increased loads. Otherwise, you will only harm the engine and significantly reduce its service life. As for conventional engines, disabling the limiters is strongly discouraged. If you do this and spin the engine above the limits set by the designers, failures will occur extremely quickly. It is possible to maximize the 5% reserve. After all, often the cutoff is triggered at 95% of its maximum operating speed. The 5% is purely for reinsurance. Such shifting of the cutoff is indeed done without significant risks, because then the values do not exceed their limit anyway. But it is strongly not recommended to try to shift the cutoff to more than 5%. This will lead to unpredictable, but for sure negative consequences. Finally, it is worth giving one simple advice to all those who like to operate the car at high speeds. Such conditions lead to increased consumption not only of fuel, but also of oil. Therefore, it is important to constantly monitor the amount of lubricating fluid in the engine, replenish it as necessary, and change it in time. Such operation reduces the service life of the oil and places higher demands on its quality. At high constant speeds, it is essential to use high-quality lubricants to minimize the wear of engine components and protect the engine from possible serious damage. In conclusion, understanding engine speed cutoff is crucial for maintaining the health and performance of your vehicle. This safety feature prevents the engine from exceeding its maximum operating speed, which can lead to severe damage and costly repairs. By adhering to these limits, drivers can ensure a smoother ride, enhance fuel efficiency, and prolong the lifespan of their engine. Always remember, respecting the engine speed cutoff is not just about performance. It's about safety and reliability on the road. Thank you for watching, and drive safely.